Hey everybody, I'm going to go over stoichiometry problems 2, 3, and 4. On a previous video I already did stoichiometry problems 1. On this one I'm not going to go through step by step. I just don't have time to go through that with all of you. What I do have is the correct setup for each of the problems. So for stoichiometry problems 2, here's our problems that we have set up. We're working with methane and oxygen, going through a combustion reaction, making water and CO2. So set this up. So for A, and let me zoom in a little bit more, you should have had this set up. Going through, pardon me. You should have started with the given, then the molar ratio, so we're divided by 32. Excuse me, not the molar ratio, doing the molar mass. And then the molar ratio is 1/2. And then the molar mass for CO2 is 44. So anyway, when we go to get these all cross canceled out, this is what we had to begin with. After we cancel everything out, I was able to get, we end up with just 44 all by itself. So 44 grams. For B, okay, you should have had set up, we had 27 grams of water, the 18 down here in the denominator. Then when we set up the molar ratio, it's 1:2. And then for the molar mass, we had 16. So when we get all of these set out, cross cancel where we can, it ends up being 3 times 4, or which is 12 grams. For part C, we're given 1 mole of CH4. We have to do the mole-mole ratios, and then we get to convert moles of CO2 into molecules. We multiply by Avogadro's number. These all canceled each other out, and it just turned out, pardon me, to be Avogadro's number. And then for part D, we were given this many molecules of methane. So we set up that Avogadro's number per mole of methane. Let's get this over so you can see the rest of it. Got to zoom out. So we get these set up, so we've got the molecules per mole. Then we have our molar ratio, 2 moles of water to 1 mole of methane. Then we got to convert the moles back into molecules. So 1 mole of water is that many molecules. So when we get everything canceled out, we can cancel out Avogadro's number twice, and we end up with our what was given times 2, and that turns out to be 6 times 10 to the 23. Now, questions number 3. So on this one, we've got iron oxide, basically rust, reacting with carbon monoxide, changing into iron and CO2. This looks very similar to one of the problems. Maybe, I don't know, maybe it's the same one on our review sheet. But working through these for practice. So let's set this up right here. Zoom in so you can see. So we were given 84 grams of carbon monoxide. We set up our molar mass by dividing by 28. Our molar ratio is 1 mole of rust to 3 moles of carbon monoxide. And then cancel these. Then we got to convert our moles of iron oxide into using the molar mass. Well, anyway, turns out that these numbers can cancel out. We get a 3-to-1 here. Then we can end up crossing out our 3-to-3, and we end up with just 160 after we get everything cross-canceled. For part B, we're given 84 grams of carbon monoxide. There's the molar mass conversion. And again, we got that because we took 16 plus 12 to get our mass for carbon monoxide. Our ratio, coming back up here to our balanced equation, we had 3 moles of CO2 to 3 moles of carbon monoxide. Those end up canceling out. And then our conversion is 44. So we end up with 84 times 3 times 44 divided by 28 times 3. We can cancel these out as shown here. And we end up, after we get it all canceled, we get 3 times 44, which is 132 grams of CO2. Question 4. Get that in there for you. So this time we've got copper chloride reacting with aluminum to make copper and aluminum chloride. And we've got two problems here to work out, so let me make sure that's number 4. So for number 4, let's get our balanced equation there. We're given 5.4 grams of aluminum. There's the molar mass for aluminum. Then we set up our molar ratios. We'll be with 3 moles of copper over 2 moles of aluminum. And then we need to, by that time it cancels out everything but moles of copper. And we set up our molar mass for copper. And we end up with these numbers down over here. And after we do all of our reducing and multiplying, I ended up reducing this to 3 times 64 over 10, which is 192 over 10, which turns out to be 19.2 grams. For part B, you're given 5.4 grams of aluminum, and so we got to use the molar mass for aluminum to convert it to moles of aluminum. Our molar ratio between copper and aluminum is 3 moles of copper to 2 moles of aluminum, and that comes out to be, after we get these cross-canceled out, 5.4 into 27, 1 over 5, we get 3/5, which when you do the math, turns out to be 0.6. And lastly, question number 5. So we've got magnesium nitride reacting with 6 waters, reacting to form 2 ammonias and 3 magnesium hydroxides. So let's take a look now at our answers right over here for number 5. So for number 5, we're given 54 grams of water, and the molar mass of water is 18 grams per mole. Our molar ratios that we're working with on this one, we have 2 moles of ammonia because we're trying to convert it into grams of ammonia for 6 moles of water. And then we end up with moles of NH3, and we need it to be grams of NH3 in this problem. So by the time we get canceled, we have 54 times 2 times 17 divided by 18 times 6 in the bottom. Well, 18 can cancel and go into 54 3 times. Okay, and then we end up here, we've got 6 times 2, 3 times 2 is 6, which will cancel now with our 6 at the bottom, and we end up that it's 17 grams. After we do all our canceling, we didn't even really need to multiply anything, just left it there. And then lastly, part B, we're given 54 grams of water. Using the molar mass for water, we divide it by the molar mass. And then we need to set up our mole ratios. We have 3 moles of magnesium hydroxide, converting from 6 moles of water. And then we end up with moles of magnesium hydroxide, and we need to convert that into grams because this is a gram-gram problem. So we end up with, in this problem, 54 times 3 times 58 divided by 18 times 6. And then we can cancel out 18 and 54, 3 to 1. And then over here, we end up over here, we can cancel off the 6 that's in our denominator with one of the 3's here, and we get 1 over to half. And then, so I got it set up here, 3 times 58 over 2. We can cancel the 2 here and make this 3 times 29, it works out. So when all is said and done, you should have ended up with 87 grams of magnesium hydroxide. So let me know if I goofed on any of these, because this is the first time I've gone over those with anybody. Man, let me know right away, but I don't think I goofed. Thank you. Goodbye.